In Pure 1 you could differentiate a polynomial in your sleep, bring the power down, knock it off by 1. But the real world is built from functions tangled inside each other and multiplied together. This unit is the full set of rules for differentiating anything: nested, multiplied, divided, even equations you cannot rearrange. There are really only 3 rules to carry, plus a short list of standard derivatives to memorize. Learn which situation triggers which rule, recall the standard results, and you can differentiate practically any expression Pure 3 throws at you. Let's meet the 3 rules and their triggers. The chain rule handles a function buried inside another, like something to the power 5, where that something is itself an expression. The recipe: differentiate the outer layer as if the inside were a single blob, then multiply by the derivative of the inside. Outer first, then inner. Peel the onion 1 layer at a time. Watch it on y equals 3x squared plus 1, all to the 5th. The outer power gives 5 times the bracket to the 4th. The inner derivative is 6x. Multiply them and you are done, 30x times the bracket to the 4th. The bracket comes along untouched, only its power drops, and the inside's derivative tags along. When 2 functions are multiplied, use the product rule. Differentiate the first times the second, plus the first times the derivative of the second. Each function takes a turn being differentiated while the other waits. Say it as a little chant: first d second, plus second d first, and it sticks for life. When they are divided, the quotient rule takes over, and it is fussier because order matters. Bottom times derivative of top, minus top times derivative of bottom, all over the bottom squared. The minus sign is where marks go to die, so write the bottom first and respect that subtraction. Low d high minus high d low over low squared. Now the short list you simply must know by heart. The exponential e to the x is the one that differentiates to itself, completely unchanged, the function that refuses to move. The natural log, ln x, differentiates to 1 over x, and sine becomes cosine, while cosine becomes minus sine, that minus being the second great Mach loser. In practice these almost never arrive alone, they come wrapped inside the chain rule. The derivative of e to the f of x is e to the f of x times f dashed. The derivative of ln of f is f dashed over f. Spot the standard result, then immediately multiply by the inside's derivative. Standard result, then chain. Sometimes y is hopelessly tangled with x, like x squared plus y squared equals 25, a circle you cannot neatly rearrange for y. So you do not rearrange. You differentiate every term as it stands, and each time a y appears, the chain rule forces a dy by dx to ride along. Then collect and solve for that gradient. Rearrange and the gradient drops out. Dy by dx equals minus x over y. Notice it depends on both coordinates, which makes perfect sense. A circle's steepness changes as you walk around it. Implicit differentiation is not a different rule. It is just the chain rule, applied bravely to a y you refuse to untangle. Last case, x and y are each given through a third variable, usually t. Think of a particle whose position is steered by time. To get the gradient dy by dx, you differentiate each with respect to t separately, then divide dy by dt by dx by dt. The t's cancel like a fraction, and the gradient survives. And notice the thread running through all of it. Chain, implicit, parametric, they are the same single idea, the chain rule, wearing 3 different costumes. Master the notion that derivatives multiply and divide like fractions, and the whole unit stops being 5 rules and becomes basically 1. Here is the whole unit as one poster. The 3 structural rules by trigger: nested functions call the chain rule, a product calls product, a quotient calls quotient. Read the shape of the expression first, and it tells you which rule it wants before you write a thing. The standard derivatives sit top right, e to the x unchanged, ln x becomes 1 over x, sine and cosine swapping with that lethal minus. And the unifying truth bottom left, implicit and parametric, are just the chain rule in disguise, because derivatives multiply and divide like fractions. And the boundary fence so you do not over-revise. You are not asked for differentiation from first principles here. That was Pure 1's job. And the inverse trig derivatives, the really exotic ones, are beyond the syllabus. 3 rules, a handful of standard results, 1 fraction idea, that is the whole game.